Hello, everyone. Welcome. My name is Mark Cohen, and in this session, I would like to kind of take you on a journey with me. Hello, everyone. I'm not sure if I started too early there, but my name is Mark Cohen. I'm a Google developer advocate. And today I'd like to take you with me on kind of a journey into the cloud, I'm calling it, which is basically I want to walk through the thought process and the technology choices involved in deploying an actual app. So let's get started. A little bit about me. I've been at Google for 11 years, actually almost 12 now, and all of the slides you see today can be found at the link at the bottom of this slide. So mco.fyi/Quizrd is available right now on the web, so you can use that to look at the slides now or later. Under my name there is my blog and my Twitter handle. My job at Google is a cloud developer advocate. So I basically help customers and developers take full advantage of Google Cloud. And I have a long history of being a software engineer myself. And I also like to teach and to write. So I really enjoy this job because it lets me combine all of those things together. So before we get started, I thought I would try to find out a little bit more about all of you. So what I'm going to do is jump to my app. This is the app we're going to kind of look at together. And I'm going to select a particular quiz. Sorry, I want to double check something. Yes, okay. And the quiz is basically a survey that I've created to ask you all some questions. So I'll just click Run Quiz. And what I'd like you to do is connect your browser to this URL. Let me make it bigger for you. It's quizrd.io/1. So QUIZRD.io/1. So if you could go ahead and try that on any device handy for you, whether it's a laptop or a phone or anything else. See, we have our first player. That's a good sign. I'll wait a minute or two for other folks to join. And by doing this, it'll give you the user experience of the app that we're about to design and build together. So I'm sort of throwing you into the deep end of the pool based on not telling you anything about this app, but I think you'll see it's pretty simple and straightforward. So I'll wait till we're up to 17 players, and I'll wait a few more minutes for everybody to get on board. People are still streaming in. Okay, things have leveled off a bit at 27 players. Welcome to all of you. I'm going to click the start button, and you should get a question popping up on your screen about how much experience you have with cloud computing. So go ahead and venture your answer. And as you can see, the summary page is giving me some feedback on how many people have responded. So I'll wait till most people have responded, and then we'll reveal the results. Normally this app is okay, we're up to 34 of 34. So I'll go ahead and click reveal. And we can see that most people classify themselves as having a little bit of experience. 8 people said none. We got some non-answers. And 4 people said a lot. No gurus so far. I'm not sure why we're seeing undefined and NA. That seems a bit weird, and I haven't debugged that yet. So you're playing with a evolving app as we speak. And you can see more people are answering, and this is dynamically updating with their responses. So that's fun to see. Let's check the next question. I will go back up and click the next button, and you'll see the next question hopefully popping up. Which cloud do you use the most? So we're getting snappier responses here, 24 out of 42, almost half of the players. Just about there. Okay, let's reveal the answer. And the most popular one is not too surprisingly, given the nature of this event, Google Cloud. 21 people said that. 10 people said AWS, and we had 5 Microsoft Azure users. Let's go to the next question. What's your favorite programming language? Always controversial and fun to debate. Yeah, this is hopefully going to be a fun app for other people to use to do this kind of interactive response stuff. We're about halfway through the players, 35 of 44. Okay, we're almost there. Let's reveal the answer. The most popular programming language, and this was true this morning as well. I did a talk for the folks in the AMER region, and Python had about half of the votes here. And similarly, this morning, 23 people voted for Python. We got a bunch of others. I'd love to know what some of those are. JavaScript and TypeScript shows up much lower in this sample than it did this morning. And NA was a high scorer. I'm not sure if that's a bug or if people didn't answer, but let's try the next question. Which part of the development stack do you focus on? So I'm going to answer that one myself. I'm glad that a lot of people said they knew a little or not much at all about Google Cloud, because I've tried to fashion this talk so that it's introductory and will help you get up to speed quickly with it if you don't have a lot of experience. Looks like most folks are web front-end people on this stream, which is nice. And we have some mobile app developers, welcome, and some server-side people as well. Let's go to the next question. What are you looking to get out of this session? By the way, if things don't work for you, let me know after the talk. My email address is mco@google.com. This is an app I've literally written in the last month or so. And as all apps, it's got some rough edges. So, you're all done here. So let me reveal. Got a few votes for learn what is the Google Cloud, how to design my application. The big winner here is NA. Not sure what's going on there, but which Google Cloud to use is actually the highest scoring item, I think. So thank you for that. And we'll click next. This is the last question. What do you think about AI? What I was saying earlier was that there's lots of rough edges in this app. It may or may not fall apart. Really, the idea here is not to present a polished application, but rather to walk you through the thought process behind how I designed and built this, and specifically how I used the Google Cloud and AI to accomplish it. But if you do find a problem, do let me know. My email is mco@google.com. AI will create new opportunities. I kind of agree with that. I also think that it will make you more productive and efficient, which got a bunch of votes. Sorry, the first one, the highest one was, it was AI will create more opportunities. I guess I need to work on the formatting here because I can't see the color of I don't know what to think about AI. So lots of UI corrections to make. AI is a double-edged sword. I can't disagree with that as well. So thank you so much for indulging me on that. You now understand a little bit about how the app works and what it does. Let's now take a little bit of a detour to talk about cloud in general and AI. And then we'll come back and we'll kind of walk through how I built this app and some of the considerations involved. So I'll stop the quiz. It should jump you back to the standby mode. You can terminate that tab if you like, and I will go back to the slides. Okay, so if you have questions, by the way, go ahead and post them in the stream. And I have some friends who will be keeping an eye on that and sharing questions with me periodically. So let's keep moving forward. I want to share a few thoughts about AI with you because I've been a professional software developer for 40 years. I started my career in 1982. So I go back a ways, and I've witnessed these revolutions before where, the personal computing era, the mini computers, of course, the smartphone era, the internet. I was around when the World Wide Web first came out. So I've seen like successive revolutions happening. And this one feels a little bit different just because it's happening so fast and it's on such a high curve of adoption and impact. So it's quite interesting. But I think what always happens with these trends is we get a little bit caught up in the everything's changing, the world's totally different from how it was 3 months ago. And in some sense, that's true. But I think a lot of the basic things that we need to do to solve problems is not changing that much. It's just that the tooling, the capabilities we have has been expanded. So rather than getting really, really excited about the AI itself, I get excited about human intelligence and learning how to teach people to take advantage of this change in technology. And that's really what I want to do today. A friend of mine posted this on Twitter, and I think there's some wisdom here. He said, as an employee, you're not paid to, this was in response to people expressing to him they were nervous that their job was going to be taken by AI. And his way of thinking about it was, as an employee, you're not paid to know something specific. You're paid to be useful. And I think that's the idea, is if you can adapt what you do so that you're understanding how to use this technology and incorporate it into larger systems, I think you're going to be just fine. And I think you're going to have more fun because you're going to be more productive. Okay, so how do you do that? How can you be useful? Some examples would be figuring out how to integrate AI into your applications, how to integrate it into the cloud, because something like AI really begs for a system that can be deployed globally with high scale, and that's really where the cloud shines. Another way to be useful is to figure out how to apply solid engineering practices when you're using AI. It's sort of easy to get excited about a model in isolation because you can do some amazing things really fast. But to take something like that and to actually put it into production with all of the safeguards, the security, the performance, the reliability, the resilience, all those things requires you to understand how to build a solution around this machine learning model or whatever it is you've built. And so I think understanding how to do those sorts of things that I've listed here gives you a good way to be useful in this new world. And that's hopefully what I'm going to help you get some insight into today. We'll basically be building an app, and I'll talk about some of those ideas as we go along. Before I do that, I would like to quickly give some background on Google Cloud so that we're all kind of on the same page about how to interact with it, how it looks. And really before I get to that, let me just sort of step back and let you know that when I started at Google, there were only 3 products in Google Cloud. So it was a much simpler world. We had App Engine, Cloud Storage, and BigQuery. And you could really kind of get your head around Google Cloud. It wasn't that complicated. As we fast forward by a decade or more, we now have a whole document just to help summarize all the different cloud services we have. And this is a mixed blessing, right? It's 100 different services or over 100 different services. So it's very rich and very powerful. But when you have too many options, it can be daunting, right? It can cause stress because it becomes harder and harder to decide what to do and how to do it in an environment with too many free parameters. And so I often have this question of, how do I learn all about Google Cloud so that I can be really effective and efficient with it? And my advice is usually don't try to learn everything. Try to solve a problem. Pick something that's really meaningful to you that you'll enjoy solving and you'll get engaged with. And then try to figure out what technology fits best. And try to resist the desire to learn everything, because you might look at that proposition and say, well, I won't know which tools to use unless I know enough about the platform. So I'm going to learn everything and come back. The problem with that is you never get back because you can't learn everything. And so I really recommend this pragmatic approach. Try to solve the problem. You may make some bad choices, but you'll actually learn, you learn through failure a lot. If something doesn't work out right, you're going to understand why and determine, what would be a better tool as your next step and what the limitations are of the tool you chose. So that's what we're doing today. I'm solving a problem that I'm passionate about, that I think is fun, and we're going to see some of the choices I made. Maybe they're good, maybe they're bad. We'll find out. Before we do that, I just want to talk about the 3 different ways you can access Google Cloud. The first way is through the Cloud Console. And that looks like this. Let me make this full screen for you and maybe enlarge a bit. So this is kind of the Command Central location for Google Cloud developers. You have everything here at your fingertips. You select a project up here, and a project is nothing more than kind of an encapsulation of a bunch of resources and configurations and settings and things like that, that kind of relate a bunch of things together into one entity. And then up here in the upper left is your navigation menu. So here's where you can select all of the different products. And if I click more products, you can see how long the list is. So this gets back to that long list of services that I told you about, but you can pin the ones that you use the most to the top of the list here. And that way you don't have to go looking for things as much. Just as a very simple example, I'm going to click on Compute Engine. I like this as an example because it's a pretty straightforward service that I think most people can relate to. It's a way to just create virtual computers in the cloud. So you come here and you can say create instance, an instance being an incarnation of a computer, just a fancy word for a machine or a computer that you want, a virtual machine that you want in the cloud. So you can tell this dialog which region you want it, which zone. You can pick a different hardware base, machine type, so different numbers of CPUs. I think you can even include GPUs with this. Not sure, that might be a separate, there might be a separate way to do that. Yeah, and then boot disk, you can configure things like the operating system you want, whether it's Linux or Windows or something else. So yeah, you do this, and then let's do, I'm just going to take all the defaults and say create, and it'll create a virtual machine for me, and you can see it's starting to think about that. It usually takes about half a minute or so. And then once it's up and running, I'll be able to click this SSH box to be able to remotely log into that machine. So let me wait just a second or two more to see if it actually finishes. Yep, okay, so it's done. So I now have a running virtual machine in the cloud. I'm starting to be paid for it. I mean, I'm starting to be charged for it. I wish I was being paid for it. I'm being charged for this machine, and there are lots of things I can do. If I'm not using it, I can suspend it or even stop it. But anyway, not to make this a talk about Compute Engine, but hopefully that is clear that you can just about anything you want to do with any given service, you can do through this console interface. So let's go back to the slides, and not there, here. The next, I'm not gonna, yeah. So the next slide is showing the second way of using this interface. It's the command line. And really the command line is just a tool called gcloud, which you can access like this. I'll make this full screen. And really the gcloud command has the ability to do almost everything you've seen in the example I just showed you on the console. So for example, I can say gcloud compute, and that's the kind of subcategory of command options for Compute Engine. And I think it's create, or I think it's instances. Let's see. gcloud compute, I guess it's singular. Instances, no, plural. Sorry. Instances, and then I think it's create. Oops, sorry, having a tough time with my typing today. Yeah, so it's telling me I didn't give it enough information. There's all these different options, and that's quite a long list because, as you saw, there's lots of different capabilities when you're using the web. But the idea is you can use this command to do pretty much everything you can do on the console. Now, the third way of interacting with Google Cloud is through the API, or the programming application programming interface, which we'll see right here. And if I click on this link, it takes me to the documentation on the Google Cloud APIs. And as you can see, depending on which programming language you may like, Go, Java, Node.js, Python, etc., we have links to the reference documentation and the GitHub repo where the client library lives. The source code is open for most of these. And so that gives you the ability to interact with Google Cloud programmatically using software. So the idea is that pretty much, I won't say everything, but most things that you might want to do with Google Cloud can be done in any one of those three modalities. So if you're doing something that's a one-off operation, maybe it's easiest and quickest to use the console. If you're doing something that maybe you want to automate but doesn't warrant a development cycle, you can use the gcloud command and kind of put it in a script. And if you're doing something that really is a kind of a product-oriented thing or a production service or something that's involved and you really want it automated programmatically, then the APIs and the client libraries are probably the right choice. So that's the background. And now let's actually talk about the application I wanted to tell you about. A few years ago, when TensorFlow came out and deep learning started really taking off, it occurred to me that a fun thing to do would be to make an app that generates trivia quizzes. This is just something I enjoy, pub quiz type quizzes. And I had this on my project list for quite a while, and I put it off because it was a lot of work. And I realized just recently, when these language models started blowing up, that this suddenly became a lot easier because this is perfect fit with the large language models. So the idea was it would be really nice to have a free app that anyone can use, have it be AI driven, so the quizzes don't have to be handcrafted by humans. And it can be something that's available for everyone. You can imagine teachers wanting to use this for their students, pub quiz night, or people just having family gatherings or some friends getting together and having fun. So I came up with this idea called Quizrd. Here's my overly dramatic fade-in slide with my logo and everything. Rhymes with wizard because it's a wizard at creating quizzes. Maybe a little bit hokey, but anyway, that's the vision for this app. And the first step that I like to stress is the planning step, which may sound obvious, but my favorite thing to do when I'm starting out on a project is to write down the requirements. This goes back to my old days in the Bell system. I worked at AT&T in the US for many years, and before we would make any changes to the telephone network, the switching systems, et cetera, we would have to write very precise requirements documents. And this kind of got into my DNA, but I found it to be very useful because it forces you to specify, to write down exactly what you're building and how it's going to work. And I find people often skip this step because they feel like, I know what I'm building. I already have my vision. I don't need to write that down. But it's super useful to do so because it enables you to communicate what you think you're doing with other workers. Eventually, you're going to have to scale your project if it takes off. But even more importantly, it's really a way for you to explain to yourself what it is you're trying to do. We often think we know what we're doing, and it actually turns out we haven't thought through all the details. And when you sit down and try to write out the requirements like this, I think you realize all the little things you didn't realize you hadn't thought about. So I highly recommend this approach, and I put it right in my GitHub repo where the code lives, and that way I think it helps give me a north star kind of thing. The other early planning thing I like to do is find the technology to build on top of. So don't try to reinvent the wheel. It's tempting to design everything because it's fun for engineers at least, but try to resist that temptation because most of the functionality in your app probably already exists, and it's going to be a lot more effective and efficient if you get into the position of finding things that work well together and gluing them together versus having to implement low-level things. It's not always the case, but oftentimes I find that to be true. And in this case, I found an app called Emblem Giving, which is a open source exemplar application that Google has put into the public domain. It's in GitHub, and it has a lot of the right structure and capabilities. It's a 2-tier web app with database support. It's using the kind of storage mechanism I wanted to use. It uses the computing technology I wanted to use, built on something called Open API, which was new to me and I learned a lot about, and which turned out to be really helpful. So find something like that that's a good fit, or a few things that are a good match for what your problem you're trying to solve, and then glue them together. So once you've got some foundational componentry and a set of requirements, you want to think about your architecture. And so at a high level, I really started thinking about, how these quizzes work. You could say this is probably an outgrowth of the requirements stage. But in a nutshell, I wanted all quizzes to be public, just for simplicity. I didn't want to have to implement a sharing mechanism initially. And that's kind of another theme, is keep it simple in your first iteration and then add more complexity as time goes on after you've proven the idea and seeing how well it works. I want people to be logged in, so I'm going to have an authentication mechanism if they want to create, clone, or run a quiz. And that's just so that I can understand who created it and make sure that other people can't come along and delete someone else's quizzes. Other than that, I don't have any interest in collecting identity information. And in fact, even the identity of the creator is not preserved in my app. What I'm doing is hashing it using SHA-256. And then I am storing that, but it's opaque to me. I can't tell, even if I can look at the string, I can't tell what email address that is. But when someone comes in and says, I'd like to delete a quiz, I can compare their hashed email address to the stored hashed email address and say, I don't know who you are, I don't know who the creator was, but I know they're not the same person or the same identity. So I'm not going to allow you to delete it. So I'm trying to respect people's privacy as much as possible, but I do want you to log in order to manipulate quizzes. Anyone can play a quiz, however. If you want to be part of a quiz participation, I don't want you to have to log in to Google or even necessarily have a Google account. So I've got the ability for anonymous play. Only the creator or the admin can edit or delete a quiz. I mentioned that. So there are really 3 classes of users: admins, creators, and players. And I only store the email addresses of the admins. The rest of the system is just kind of works de facto. If you're logged in, you have certain privileges, but it doesn't matter who you are. Got a couple of questions here. Can we train a local Quizrd on our own corpus? Yes, I think that's a cool idea. I think you'll see that the model I'm using is going to get you like pretty far along right off the bat without having to do any such work. But if you really want to fine tune the model and make it like the best quiz generator engine on the planet, I think the right way to go would be to build your own model and train it with some corpus that's relevant to your domain. Another question we got was, how do you know what the requirements are? That's really the essence of the requirement process, is you don't know what they are and you have to kind of sort through that. And so the way I like to think about the requirement generation process is to ask yourself, I'm an end user of this system. What's it going to look like? How's it going to work? What options am I going to have? What capabilities will be presented to me, and how will they look, and how will they work? So try to imagine what your system will look like to somebody who knows nothing about it, right? The mistake we often make is we think about it with our own internal view, and we've been thinking about it for weeks and months, and we kind of have this internal image of what the product's going to look like. Try to put yourself in the shoes of someone who hasn't thought about it or seen it. What will it look like to them? What will it have to do? And that, I think, will drive you towards this process of formulating what your requirements are. Okay, so let's keep going here. So I've defined these 3 personas on the right: the admin, creators, and players. And coming out of these requirements, I found 4 different entities. I'll say data entities. We have admins, that's the list of privileged admins. As I said, I only need to enumerate those. I don't need to enumerate the creators or the players. We have this notion of generators. So I came up in my requirements with a notion that I wanted the quiz engine to be pluggable or modular, right? So I didn't want to say like, I am hard coding this app to generate quizzes with Palm or ChatGPT or whatever, because there's going to be some new capability that comes along that's going to be better. And I want it to be very dynamic and adaptable. I also want the capability of having different generators, and you can choose which generator is best for your quiz. So I have these modular plugins called generators, and they actually create the quizzes. There's a representation in the data model for quizzes themselves, which has, of course, questions and answers, but also lots of metadata, as you'll see. And then there's a data set of results. And for any given quiz, there's a set of answers that have been submitted by the players. So that's the data model. And the way these two sets of things interact is the admins can manipulate the admin list and the generator list, so they can install new generators or delete a generator and so on. Creators and hosts can read the generators, not write them. So why would they need to read the generators? When a creator is creating a quiz, they need to know what's the menu of possible generators I can use. And then they, of course, store quizzes after they use the generators to generate them. And then finally, the players can read the quizzes so they can participate, and they can write their results for a given quiz. So that kind of covers the model, the whole data model. And I think you probably, I don't know, I feel like it's not that complicated for this kind of application. So I'm happy with that. This is the flow, kind of a block diagram level flow of the creator and hosting flow. So whether you're creating a quiz or running a quiz, you would come into this website. That would be one entity, and the website would make requests to this other service, this sort of backend service called Content API. And that entity would do the actual storage and retrieval functions. So this is kind of a like a traditional three-tier web application where you have a front end embodied by this website, a middle tier, which is serving up an API to the front end, and a storage tier, which is actually, managing the storage of the quizzes and all the other data items. The player flow looks like this. The player would use the same website to get access to the quiz and the quiz questions, and then it would post its answers and interact further with the quiz, the running quiz, by interacting directly with the storage layer. So I'm looking for a storage layer that supports both server-to-server access and secure client-to-server access. And we'll see how I solve that in a little bit. But the reason I wanted this direct path was I didn't want, when there's a lot of quizzes going on and a lot of players potentially in a given quiz, I didn't want everything to go through this website, which could be a bottleneck. So I like this distributed model where you can post your results independently of other players, and we'll get some performance out of that. This is the DevOps model, which is how we actually manage and deploy. We have a developer pushing a pull request or a merged set of changes to GitHub, which automatically triggers Google Cloud Build to rebuild everything and reprovision with Terraform. I use this thing called OpenAPI, which lets me specify the interface between the front end and the back end, or the web server and the Content API, using a text file, a YAML file. This is really a nice capability because I just specify the interface in text and it generates the code for me. So I actually don't have to write any of that functionality myself. It also generates documentation, which is pretty cool. And then that spits out some Docker images, which go into the artifact registry. It's another Google Cloud component. And then it has the ability to initialize the database in Firestore. Didn't even talk about Firestore yet, but we will shortly. And then the artifact registry has these images which get deployed to Google Cloud Run, and we'll talk about that as well. So a bit of foreshadowing there. Sorry to be using terms I haven't defined yet, but let's take each kind of dimension of this problem one at a time and talk about some choices. So the storage engine, this is sort of my wish list for what I want. I want auto-scaling and serverless. I don't want to actually think about creating virtual machines. I want that to be taken care of for me. The quiz data and really all of the data in this system, I think, fits with JSON as a nice way of representing it. I like that because it's textual, so I can read it. It's not as efficient as a binary representation, but it's very helpful for debugging and inspection. And it's also hierarchical, so it fits into this sort of object notation very nicely. Most of the queries I want to do are finding the right JSON object in this hierarchy. And so NoSQL, which is sort of like key value type, supports key value types searches, is a very nice query syntax for me. I don't really need or want, in this case, the traditional relational model where I have tables and fields and foreign keys and all that stuff. Nothing wrong with that. But for me, this is a simpler way of going for this particular application. I want real-time capability. So if you remember, when I click that next button to say, let's display the next question, it virtually immediately updated all of your screens to show you the next question. And I want that pseudo real-time capability so that I can coordinate a quiz across a large number of users without having to say something like, refresh your screen now to see the next question. That wouldn't be a good enough user experience. And I want both the server and the client server to be able to function concurrently. I already spoke about that, why I would want that. So Google has a bunch of different storage options. I'm not going to go through all of these, but depending on what your needs are, there's very likely to be something in this array that's going to be a good fit for you. And the one that I ended up choosing was Firestore. And it basically ticks off all the boxes that I specified in my wish list. You can read more about it, obviously, but I'm going to show you what it looks like sort of interactively. So here is the Cloud Console view of a Firestore data collection. You can see these objects that are the same ones I showed you in my data model: admins, generators, quizzes, and results. If we can look at a quiz, for example, here's the Q&A. That's the JSON encoded questions and answers. Active means it's not being run right now. Anonymous, whether the users can play anonymously or not. It's multiple choice. The creators, here's that hashed ID. Obviously, you can't tell what that email address is, but I can use that to tell whether anyone who's trying to manipulate this quiz is the original creator or not. Description, difficulty level, lots of different metadata about a given quiz. Time limit, how many seconds I want to allow. Here's the topic, and so on. And then here's the results field where I keep track of all of the answers that have been supplied so far on a running quiz. So fairly straightforward, and the Firestore console gives me the ability to inspect this very easily and make sense of what I'm looking at. So a lot of times when I'm debugging, something may not seem right, and I'll go to this console and I'll figure out, okay, this field is for some reason wrong. And I can actually edit the contents of these fields right here without having to write any code, which is nice because that gives me the ability to test, do some what if type testing. So that's my storage engine. The next, keep doing that, picking the wrong window. The next thing that I want to look at, let's go back to full screen, sorry, is the computing. So I've got these different computing elements. I have an API, I have a web server. Where do I run them and how do I run them? And again, I find it helpful to create a wish list. So again, I want auto scaling and serverless. I don't want to think about, in the old days, I would allocate a virtual machine for it. And then if it got popular, I would put another machine in the pool and put a load balancer behind it. And then eventually I would have to start worrying about scaling it up more and more. I don't want to do any of that anymore. This is a new era where the cloud provider can take care of that for me. I just want to put my computing elements out there and let the cloud scale up and down as needed. So that's really important to me. I only want to pay for what I use. If my service is not getting any attention, I don't want to bill. If it's getting a lot of attention and it's super successful, I'm okay with having to pay more. I'd like built-in TLS support, so encrypted traffic to my site. I want to be able to put a custom domain easily and do traffic splitting. Let's say I have two different versions and I want to do an A/B test, or I want to have a canary release. I want to be able to do all that easily. So again, just like with the storage, there's lots of options in Google Cloud. And I recommend looking these over and figuring out, this is not as bad as the 100 services thing. This is 5. And so I recommend looking these over and thinking through which of these services is the best fit for me. And when I did that, I found that Cloud Run was the best choice. So I've built these 2 services, and they have the exact names you saw before in my earlier flows, my architecture flows: website and content API. The website, again, is serving up the user experience on the web. And content API is an API server, so it's a programmatic service that the website is making requests to, and the content API is enforcing access control and making sure you're allowed to do the operation you want to do, and is actually carrying out the storage and retrieval type operations. So I thought I would give a quick demo of why I thought Cloud Run was a good example for this, or a good match, rather, for this problem. So the way I'll do that is to show you a simple app that I've written called Hello, which is what it sounds like. It's Hello World, all with a little twist. So just trying to grow this window and make it bigger for you. So this is a Flask app, which is Python. Flask is a Python library for serving web content. And what this app is doing, the primary thing it's doing is right here. It's got a route for /. So if you just visit the root of the URL where this program is being served, it will run this say hello command function. And what it's doing here is generating a random color, HTML color. Then it's incorporating that color into a CSS style specification. So style equals background color, and then the string I generated just in the previous statement. And then it incorporates that style specification into an HTML spec, which is just a header, an H1 header, where the style is telling it what background to give it. So as you can see, it's saying hello world with random background color. That's all it's doing. And we can show you how that works by actually running it through Python. Py is just my short alias, command alias for Python 3. That's not what I wanted, and that's because I'm running something else. I'm running my Quizrd app on that same port. So I've canceled that, and let's refresh. It might automatically work, but let's refresh this. And if we're lucky, this will now, yep, there's our Hello World app. And as you can see, every time I reload the app, I get a different random background color. So that's fun. I can even add a suffix, hello startups. And instead of hello world, it says hello startups. Very sophisticated application. Okay, so that's cool. And I'm going to cancel that. And just to prove that actually I was really doing that, it now can't reach it because I've stopped it from running. Now, you can ask yourself, what would happen if I tried to share this code with someone else? And I apologize for people who are already very well versed on containers, but that's kind of where I'm going with this, is to try to explain why containers are so powerful and so important. So the problems that could happen are, if I gave you this main.py, you might have a different version of Python, you might have a different version of some of these dependencies, you might have a different version of Flask, and it might break. It might or might not work in your environment. And so one way to kind of corral all these moving parts is to combine the app with all of its dependencies into what we call a container. In this case, it's a Docker container, a particular type of container. And so I've got a little file here called Docker file. This is the standard file for defining a container. You can think of this as a blueprint that specifies how to build the container. So it says start with a special container image called Python version 3. add a couple of source code files. You see my main.py here, and requirements.txt pulls in the list of dependencies. This pip install says install those dependencies right into the container. And then this command line says run this command when it's time to invoke the container image. So I've got, sorry, I should have full screened this. I've got a couple of scripts. I've got one, just this very simple shell script called ldeploy. And all this does is sets an environment variable and then does a Docker build, which turns the Docker file, or it creates a container image based on the input from the Docker file blueprint. And then it runs it locally using the Docker command. So I'll do ldeploy. And it's should build it pretty quickly because I haven't changed it. And Docker run tells me it actually started it running. So I should have a running container. If I say Docker PS, there it is right there. And now if I go back to that website, that same URL, I get hello startups again. So it's exactly the same as when I said Python main.py, except now it's running inside this container. And I can prove to you that I'm not cheating by doing docker stop 1101. You can use the first 4 digits of the container ID. If I now say docker PS, you'll see it's not running. And if I now try to reconnect, there's nothing there. Okay, so I sound like a magician with that. There's nothing up my sleeve. But the cool thing is now I have a unit of computing that I can share with anyone that has all the dependencies. So it's almost guaranteed. I'm going to say almost for some subtle reasons based on your hardware and so on. But for the most part, it should run anywhere just fine. And so that's great. But now what happens when I want to share that with someone else? And that's where Cloud Run comes in. So instead of this ldeploy, which means local deploy, I've got a script called rdeploy, which means remote deploy. And it's almost the same. It does the same Docker build as previously, but in this case, it does a Docker push. That's to deposit the container image in a registry, a global resource where we store container images. And then instead of running Docker run, I'm going to say gcloud run deploy. So this is going to deploy this container image into Cloud Run. It's going to give a bunch of parameters like the name of the app, the image name, so where I just deposited that image, I need to reference that, what region I want it to run in, what project, what cloud project, and so on. But I'll actually run that right now, and you can get a sense for, let me time it. You can get a sense for how long it takes to deploy. It just built the container, and now it's deploying the app to Cloud Run. And it should just take a few more seconds. One thing it will do when it's done is give me a URL that it generated to let me access the app. And it's now done. It took 22 seconds, not bad. And you can see right here, there's a URL to my new app. If I click that, not unsurprisingly, you see what you've been seeing all along. But this time, it's being served up globally on the web. You can actually type this URL and you will see it as well. And what's really special about it, there are a few things. It's HTTPS. It's got encryption. I can easily assign a domain name, custom domain name to it. But what's really special about it is if thousands of you suddenly hit this because you just can't wait to see Hello World in a random color, Google would scale the service automatically to accommodate that demand. And in fact, I have one more demo to show you. If I can find it, here it is, which is a load test of this exact site. So let's go here. This load test is configured. I'll start it running again. It's configured to do 1,000 clients over 30 seconds. So what this is doing, it's starting up 1,000 independent computing threads. This is a third-party service, loader.io, by the way. And what it's doing is it's trying to hammer on my service by sending 1,000 requests every second for 30 seconds. Now, 1,000 requests isn't that much, you know, in the grand scheme of things, but it's a nice way to kind of shake the app a little bit into a higher performance situation and to really test how it reacts, how it responds to increased demand. So that test is over. You can see it did 29,000. It should have done 30,000. I'm not sure, there's some sort of a little glitch there, but the green line shows you the number of clients, which started at 1,000 and kind of stayed there until the end. The blue line is the response time, which is suddenly sort of spiked. And I think you can infer from that that Google realized it needed more resources. And so it quickly allocated within the first 10 seconds. Usually I see it even sooner than that, like 5 seconds, more computing instances. So that brought the response time back down to like on the order of 60 odd milliseconds. So this is the kind of thing where if you did get a lot of demand and had to provision hardware, you'd be hard pressed to do it, even if it was virtual machines in the cloud. You'd be hard pressed to do it this quickly. But by using Cloud Run, within seconds, Google realized you've got a lot of demand, you need more capacity, and boom, within seconds, I've got all the capacity I need to bring that response time back down to 60 milliseconds. So that's super powerful. Okay, let's get rid of this, and this. And let's go back to our slides. Already showed you that. Sorry, I clicked on that slide and it's a link. So it looked like I was still on the same page, but I wasn't. I actually went to the loader site. Okay, back to the real world. Let's talk about analytics. If you're running a site like this, which is gathering a lot of data, and it should, right? Because you want to know what's going on, how your site's behaving, what's happening, how your users are using the site, etc. You want to store a lot of analytics. And so I want to have the same kind of world in my analytics subsystem. I want auto scaling. I want serverless. Once again, I don't want to think about computers. I want to think about my service. It should be fast and high capacity because this typically ends up being quite voluminous. And I'd like it to be integrated with other data services so that I can, create dashboards and visualize the data and so on. So BigQuery, I think, is a great solution for that. I'm not even going to go through this slide, but BigQuery is Google's data warehouse service. It makes it super easy to store large volumes of data and to see really great performance when you're storing and querying data in this engine. So it's very powerful. And rather than talk about it, I'm going to show you a demo of it. Before I do that, I see I got a question. Can you explain more about ldeploy and rdeploy? More ldeploy, more is just a command line tool to show what the contents of that file are. And more rdeploy is just displaying the other command. ldeploy was deploying it locally, running Docker to run it as a container on my laptop. And rdeploy was taking the container, building it, and pushing it to Cloud Run. Stick around at the end if that's not clear, because I'll be happy to wait and take questions beyond my time slot here. So I just said, rather than talk about it, I want to show it to you. If I click on this, it takes me to the BigQuery console. This should look familiar because it's the same cloud console we looked at before. What I'm doing here, there is a data set in BigQuery that I've actually been responsible for maintaining, which is called BigQuery Public Data Wikipedia Page Views _ and then a year. So I've been gathering the Wikipedia page view logs. Wikimedia Foundation publishes these page view tables once an hour, and they aggregate every article that's been looked at. It's all anonymized, so there's no idea who was looking at what, but it just has counts of, this article with this title was accessed this many times in this hour. So it's a barometer of popularity, if you will, about Wikipedia pages and page content over time. So it's a very interesting data set. And I've been gathering it and putting it into BigQuery so that I can ask questions about it and visualize it, basically. So this is an example of that. I'm going to show you a query. BigQuery supports SQL standard SQL syntax. And so I'm going to show you a query that interrogates this page views table and looks for any articles that have a title, the Beatles, where the part can be capital or lowercase t, and Beatles part can be upper or lowercase b. So I'm using this technology called regular expression, which is a way of just specifying kind of a syntax that can accommodate lots of different patterns. This is very powerful, but it's also very expensive to do on every line in a data set. And this data set has billions of lines. So it should take a long time, but as you'll see, it's actually surprisingly fast. I'm going to make sure I have caching turned off. I don't want to use a previously cached element and cheat. So now I'll click run, and we can watch it run in real time. If I do job information, we can see that, okay, it already finished. So let me go back to job information. It took 7 seconds to process 739 gigabytes, so almost a terabyte in 7 seconds, which for me is still, I've been playing with BigQuery for almost a decade, and it still kind of almost doesn't feel, it feels magical to me, to be honest. The other thing that's really amazing about this is if you look at the execution details, you can see how many lines, how many rows we had to scan in this table. You can't see it because I think my screen is, there it is. So records read 18,593,751,314. So it actually scanned 18 billion rows and applied this regular expression to those 18 billion rows in whatever it was, 6 seconds, 7 seconds. So hopefully that gives you a sense of how fast and how powerful it is. This kind of interactive query is really, this kind of speed is game changing, because the faster you can ask questions about your data, the faster you can iterate and understand what's going on. So if it's not obvious, I'm a very happy BigQuery user. In fact, get rid of that, get rid of that. Another way to think about this is that, I keep doing that, sorry. Hopefully not inducing motion sickness on people here, but another way to think about, I'll click on the title bar. Yeah, I was in the console. Okay, I think I might keep some of these not full screen because it makes it less likely I'm going to make that mistake. So sorry about that. The way I like to think about this is, in order to do the query we just did, if you had to assemble your own collection of hardware, you would probably be talking about on the order of 1,000 disks and 3,000 cores. How did I come up with those numbers? I just looked at the cost of running regular expressions in a very simple program and sort of extrapolated how fast it would run on a laptop or on a commodity server, and then extrapolated it to the amount of queries I'm doing per unit time with this BigQuery session. And this is sort of what the numbers that fell out. I would take this with a grain of salt. It's a very rough approximate calculation, but the point is you're getting thousands of computing elements. And basically what's happening here is Google's saying, okay, in order to do this with the kind of speed you just saw, I'm going to allocate 1,000 disks and 3,000 cores for you for 10 or 20 seconds, and then take them back and let other people use them. So this is, to me, the pinnacle of serverless computing, because I didn't have to even think about anything related to resource allocation. I could just focus on my SQL query, and the cloud provider took care of making everything, arranging everything so that the query would complete as fast as it possibly could. So really happy with that approach. Another nice capability with, get some of this out of the way. Is sometimes you will want to visualize your data, and that's where Looker Studio comes in. So with Looker Studio, this gives you the ability to create really nice looking dashboards. This is one that I built based on some life expectancy data. where I can select the countries and the years I'm interested in. And I've integrated a map, obviously, with this. And the nice thing about this is I didn't have to write any code to produce this database. I was able to just kind of do drag and drop. And this is actually pulling data out of BigQuery in order to produce these results. So it integrates very well with BigQuery, but you can also use lots of different other data sources like Google Sheets and CSV files and all sorts of different things. So it's a very powerful data visualization platform that works really well with other cloud analytics tools. Did it again. Okay, let's turn the corner and talk about AI. This is sort of the most interesting part for me because this is the new stuff. And what I'm used to is, thinking about applications without this kind of machine learning approach with, how do we solve this problem algorithmically? And machine learning kind of changes the equation quite a bit. So this was a big learning curve for me. And to go back to my earlier statement about, how do you learn all about cloud, try to solve a problem with it? I think the same thing applies to machine learning and AI. How do you learn all about AI? I think you don't try to learn all about AI. I think you, for me at least, pick a problem that interests you and try to solve it using AI. And I think you'll get a lot out of that experience. Certainly that's what this did for me. One thing that was interesting was I found AI kept popping up wherever I looked. And so I'm just checking time here, how I'm doing on time. I'm 1 hour in, and I think, I think I have another 15 minutes. Obviously, the first thing I wanted to use AI for was quiz generation. That was the inspiration for the whole project. But I also thought this would be cool to be able to generate an image for each quiz so that there's a little handy when you look at these cards that summarize the quizzes, you'll see something about the quiz that's visual. And that's a perfect application for text-to-image generator. The next problem I bumped into was not every quiz is multiple choice. Some of the generators will generate free-form answers. So if you think of like the TV show Jeopardy, where there's one right answer, you're not choosing A, B, C, or D. Grading those is actually quite different. It's quite difficult because people can express an answer in many different ways. And every single question might have different rules about how to answer it. And that's a case where I think embeddings is going to be very useful. And I haven't tackled that problem yet, but I'm looking forward to that. I think it's going to be a fun challenge, and I think it's a perfect fit for embeddings. And Google has a product now called Matching Engine, which is super powerful and fast at generating embeddings. If you don't know what embeddings are, the way I like to think of it is it's mapping data, multimedia data, into essentially collections of numbers. We call them vectors, but they're really sequences of numbers that kind of position that data in a unique space that has relationships with other data. So it'll be closer or farther away from other pieces of data that happen to be closer or further semantically from that data. So you can think of like embedding the answers and then the correct answers, and then embedding the user's answer and trying to assess how far away in this embedding space is the user's answer. And that will give you a probabilistic estimate for how likely they're to be right. It's not going to be black and white. It's not going to say, yes, this is right or this is wrong. But that's true in real life too, right? Like two people might look at an answer and one might say it's close enough, it's correct. One might differ. So this embeddings will hopefully help me solve that problem. I'm looking forward to learning more as I do that. So if I just step back and talk about the LLMs, these are the technical issues I faced. One is the quality. The very first version of this app generated quizzes that I will generously say weren't so good. Accuracy, right? These LLMs are known to lie profusely. And so how do you know the answer it's telling you actually makes sense? That's kind of an interesting challenge. Reliability. What did I want to say about that? I initially was querying the language model for a quiz, asking it to generate a quiz, I would take the questions and answers it gave me, and I would encode it in, as I said earlier, JSON, because that's kind of how I'm recording everything in this app. And then the light bulb went off for me one day. I was like, why don't I just let it give me the JSON? Then I don't have to parse it from whatever format it's feeding me and turn it into JSON. And it turned out to work beautifully. However, every once in a while, it gives me a not perfectly formatted JSON document, and that can cause it to fail to generate a quiz. And so the reliability question there is, how do I avoid that where I get bad formatting? And then, of course, responsiveness. It's a little bit slow when you're using these language models, and I wanted it to be something that would be snappy and quick. So the first challenge, quality, the way I've attempted to deal with that is through iterating on prompting. And there's a whole school of thought nowadays on prompt engineering, but some of the key learnings that I came across was, first of all, templating was really helpful. So I constructed a prompt that works very well in general for any quiz, and then I can just replace the topic with the user supplied topic name, the number of questions, the level of difficulty, etc. And so it's sort of like a cookie cutter prompt, and I just plug in the specifics that the user wants. It's very important to request the desired format. I already talked about that, but I ask it for JSON representation, and it seems to do very well at that. And it's important to be specific. The early quizzes were kind of repetitive, like, who's the first person to do this? Who was the first person to do that? And after 3 of those, you're like, can you put some more variety into these quizzes? So be specific about things like that and give lots of examples. Doing these things ended up performing reasonably well, I would say. I'm not super delighted yet with these quizzes, but they're getting better. I think the ultimate answer will be to create a custom model trained on, as the questioner, Martina, I think, asked, training on a specific data set that's really built to do this kind of function. But I'm pretty impressed with how it does so far. Accuracy. A good way to handle that is with this human feedback kind of approach, where I don't have this implemented yet, but every time you answer a question, I'm going to pop up a thumbs up or a thumbs down, and you're going to be able to rate the question. Was this a good question or not? The model still produces some who was buried in Grant's tomb kind of questions. And so I want to be able to have users rate the question, and then based on that, I can give feedback to the model and hopefully tailor its results to make them better quality. I want to consider using the LLM to verify its own output. So the model may do a lot better with a direct question, like, did this person invent this thing? Another option would be ask a different LLM to cross-check the first LLM. I think there's some interesting things to be done there. I'm not sure how well that's going to work, if it lied about the trivia, maybe it'll lie about the direct question. That's an open question, but I'm interested in seeing if that is fruitful. The downside of this is it adds significant latency. Like, I don't want to ask an LLM a question every time. For every question it generates, I don't want to have to then ask it, does this make sense? Does that make sense? Because now it's like you've multiplied the latency, which is already bad, by the number of questions in your quiz. But my idea to do there is to have an optional on-demand validation function. So the creator of the quiz can press a button to say, I'd like this quiz validated. And then there's an understanding that, okay, this is may take a little while longer, and you can go back and come back later, or it can show real-time progress to see how it's doing. But again, I think the real answer is a custom model. I talked about this problem, the validating the JSON output. It's tricky, but there are JSON validators available that have nothing to do with AI, so they're not fuzzy. They're all or nothing. This JSON is parsable or not. And I think I should be running the quiz output through the validator before I try to do anything with it. If it fails the validator, then I should regen the quiz up to some number of retries and keep the user informed. Again, with experiencing a problem with this quiz, it's going to take a little longer, whatever you want to say. And of course, log these events so that I can monitor over time how often this is happening. Responsiveness is a big problem, as I mentioned. I think that the way I think about this is like back in the old days of dial-up internet, we're living in the 2400 baud modem period for this technology. So it's sort of like you can do amazing things, but it's pretty slow. It's well suited to one human being sitting there doing a query and waiting for a reply in real time. Even that can be a little slow. But if you're building an app like this, which you hopefully want thousands or millions or whatever users to be able to generate quizzes and run quizzes, you really want this technology to be fast enough to not feel like you're experiencing latency. It's not that way yet. It will get better soon because we're on this, Moore's law kind of curve in the AI world and everywhere else in computing. But in the meantime, we have all these old tricks we have, which is do things asynchronously, parallel processing, caching, etc. So those still work. And with that, it takes me to my final demo. So I want to jump back to my app. Let's full screen that. And we're going to create a new quiz. And that failed because if you remember, when I was doing my test, I stopped the local server from running. So I'm going to go back to my Quizrd directory, and I'm going to run test.shell, which starts the server running locally. Takes a second or two to start up. There we go. And now I should be able to navigate to my local host 8080. Let's full screen it. And there it is. So now let's say, so you can see these cards here. These are those images that I mentioned. I can say create new quiz. Can anybody give me a quiz topic? For generator, by the way, I'm going to use Palm, which is Google's version 2 chat and large language model. And for the topic, not seeing anything, but I'll call this test quiz for startup event. That's more of a description than a name. Let's put that down here. I'll just say test quiz up here. Not seeing any suggestions, so I'll come up with one. Let's say science fiction. So I can specify things like the number of questions, the number of seconds to respond. The generator temperature has to do with how much randomness we see in the data, difficulty level, and so on. Lots of different things I can specify here, but I'll just go ahead and click create. And now you're going to get to, let me bring it out of full screen so we can see what's happening. Now you're going to get a sense of the latency I mentioned. There's two things that are happening. There's a bit of latency with generating the quiz, but that's actually not the slow part. The slow part is generating the image, which you're seeing happening here. Okay, it finished, wasn't too bad. Kind of cool that I got an AI generated image for my science fiction quiz. But that took a little longer than I would like it to take. Now I'd like to invite you all to participate in this quiz. So I'm going to have you connect just like you did before, but instead of using /1, we're going to use /4694. But don't edit the URL you already have in your actually, let me click run quiz. And we should see how many people are running. So Randy was quick off the draw there. Randy's already logged in. Go ahead to quizrd.io/4694. Welcome, Hussein. So quizrd.io/4694. I'll wait for a few people to connect so we can have a contest. And I am at my time limit, so I'm going to keep going. But if you have to be somewhere else, feel free to drop off. I won't be insulted. I won't even be able to tell probably. But yeah, if you want to stick around longer, we'll play this quiz, and then I'll be happy to take any questions. I got 14, 15. I'll wait till the numbers slow down. 16. Quizrd.io, quizrd.io/4694. Hopefully I'll invent some easier way to rendezvous, but at the moment it's Not too bad of a URL, but it could probably be improved. Okay, we're 20 players in. Let's do our science fiction quiz. Actually, let me connect too so I can see the questions. 4694. Okay, so all of the people in should be seeing standby. Quiz hasn't been started yet. And I will now click start, and you should see the first question. The film War of the Worlds was based on a book by which author? I think I know that one. And we see 7 responses from 23 players. We can watch the count go up as people respond. Just pick something if you're not sure. I don't want to cut you off, but I'm going to click reveal now to see the answers. And H.G. Wells was the #1 answer, and that was the correct answer as well. Let me bring the size down so we can see the leaderboard. Obviously, we have a lot of people tied for first. Let's click next for the next question. The name of the ship in Star Trek, the original series. Pretty easy. Let's see who the science fiction buffs are out there. Okay, I'm going to click reveal. Click an answer if you haven't yet. Sorry for rushing you. I just don't want to make people wait for too long. Okay, here comes the reveal. I think you can actually answer after the reveal and it'll register your answer. So there's no problem with that. There is this bug with undefined and NA. I think NA is people who didn't answer, but I'm not sure why it's coming up with some undefineds. Anyway, the correct answer was U.S. Enterprise, and we still have a pretty big tie for second place. Next question: the name of the artificial intelligence in 2001. Have to be a certain age to know this one or have seen this movie, but see what we get there. Okay, I'm going to click reveal in a couple of seconds. If you still have your timer running, I think you can register your guess later. Here we go. And the answer was HAL 9000, which people speculated at the time was interesting because H, A, and L is one letter away from I, B, and M. And IBM, of course, was the computer wizard of the age. Let's go to the next question. What is the name of the planet in Star Wars where the Jedi Temple is located? We've got the obligatory Star Wars and Star Trek questions in this quiz. I'll click reveal. And the correct answer was Coruscant. We're now down to 2 leaders. Fran and Jacob are atop the leaderboard with 4 correct. And let's go to the last question and see if one of those 2 can take first place. What is the name of the android in Blade Runner? I got that wrong. I'm going to leave this one until everybody answers because I want to have the dramatic reveal at the end with our leader. Everyone pick something. "21 of 29, 22. I think we may have had some drop off. Okay, 25. Let's go ahead and click reveal and see who won our game. The answer was Raquel, not sure how to pronounce that. And it looks like Leo and Fran didn't get that one, but a few people did get it. So we have at least 5-way tie for first with 4 out of 5. Very well done, Leo, Fran, Brandon, Randy, and Jacob. That's it. If I click next, we go back to the initial state. You should see the standby dialog, and thank you for playing. I'm very happy that demo seemed to work. Again, let me know if it didn't, mco@google.com. We have more people registering to play again. I hope that was fun for you. I'm having a lot of fun playing with this app myself. And yeah, I'm at the end of my time. I'm actually over time. So I just want to say thank you so much for spending your morning or your afternoon, depending on where you are, with me. There are a couple last things here that I wanted to share, but you can check out the slides to find out more. The Jumpstart solutions are prepackaged web apps, or apps in general, cloud apps that give you kind of the same advantage I got with that foundation app that I started with, but for different use cases. You can get free access to Google Cloud via cloud.google.com/free. And my pitch I always like to share in all my talks is whatever you do with cloud or with AI or anything, try to make it available and accessible to everyone, because I think we're all better off if it's not hard to get to and it's not hard to use and it doesn't require you to be a PhD in computer science. And with that, I thank you very much for your attention and joining me. And I will stick around for a little while in case anybody wants to ask questions. But thank you so much. Hope you enjoyed it. I see one question that came in. How do you account for non-human views? I mean, the data could be skewed if it's automated traffic. I think that's probably referring to the Wikipedia page views. And the answer is a big I don't know. I can't tell from the log files which of those page views are people. There is like probably some way of identifying the agent in some headers when you do a HTTP fetch to tell automated agents from people. But A, that's not very reliable. And B, I have no idea whether the log data I get from Wikimedia Foundation is attempting to do anything that sophisticated. So I don't really know how much of it's human generated traffic and how much of it might be machine generated. So good question. Another question that came in is, how can I integrate third-party software like GitHub for code storage in my build pipeline? Does Google have any alternatives that are native to cloud that you would recommend? And the answer is yes. We have something called Cloud Build, which can build stuff directly from GitHub or any Git-compatible source code repository. The way you do this is there's this product called Cloud, sorry, I'm blanking. It's Artifact Registry, Cloud Artifact Registry. It's the same thing where I was depositing my Docker container images. You can create repositories in that product that mirror GitHub repos, and then Cloud Build can access them in a cloud native way. So yes, you can develop your software on GitHub, and you can set up Cloud Build to be triggered when something interesting happens in the GitHub repo, like a pull request or a branches or something, you change in a branch or something's merged into a particular branch. And that can fire off a Cloud Build event, and then Cloud Build can go in and figure out what's changed and what it wants to do in order to rebuild your target. I got the, can you explain more ldeploy and more rdeploy? That's a duplicate, I think. The more command just displays text, and ldeploy is to Docker, and rdeploy is deploying remotely to Cloud Run. And so if you wanted to, so you create a Docker image, and it's this self-contained bubble that contains an application and all of its dependencies. And then you, if you run ldeploy, all that was doing was running the Docker image locally. So the Docker tool comes with support for running container images right there on your laptop. But if you actually wanted to run the container image in a public space where other people could access it, then you do what I did in rdeploy, where I pushed it up to Cloud Run, and then anyone could run it. ldeploy and rdeploy are my own little shell scripts. They're not thing. If you Google them, you won't find anything interesting. or you might, but it won't be the things I was showing you. What level of overhead am I looking at if I switch to container deployments? Any easy way to get started with containers? It really depends on your situation. Some apps are pretty straightforward. I've seen some apps that are a nightmare to containerize just because there's huge constellation of microservices that have to be every one of them has to be touched and changed and encoded. As a general rule, I think containers are a good investment, not for every possible use case, but in general, I think they're a good investment because they bring you this insulation and modularity that enables you to move your app from one place to another. So for example, let's say you're using one cloud provider's. Yes, these containers have become like atoms for computing, like the indivisible modules for doing computing. And because everyone in the industry has recognized them as this atom, they are portable, right? You can move them from one provider to another. So if you're using cloud provider A's container hosting environment or running environment, maybe it's Kubernetes, maybe it's some other kind of like Cloud Run type thing that's a higher level of abstraction. But if you decide you don't want to use that cloud anymore, you can move your work to cloud provider B for whatever reason. And this becomes this sort of portable execution environment that you can take with you more readily than if you have a more old-fashioned kind of monolithic application or collection of stuff spread across machines. So I think I think we'll call it a show. Thanks again to everyone for joining. My email is mco@google.com. Feel free to reach out if I can help you. And thanks again. Have a good day.